Hello, and welcome to chapter 4. Today we are going over routing concepts. So in today's lecture, we will go over the routing concepts. Like I said, the initial configuration of a router. I think we discussed that last semester, but we'll repeat that again. Configuring a host name and the IP address on a router. How does the router make decisions to route packets finding the best path to the destination, and how does the router operate by itself? Okay, so again, I'm going to ask you questions as we move along. So please don't forget, write these answers on a separate Microsoft Word document and submit that as homework. All right, so let's move on. The characteristics of a network. In general, the network should have a topology, how it's physically and logically connected, what subnets they belong to, how are they physically connected, meaning how the devices are physically connected to each other. Speed, if it's fast Ethernet, gigabit Ethernet, how much is it going to cost? As a fiber optic, it might cost you a lot of money. How well is it secured? Do you have firewalls, IPSs, etc.? Availability. Do users have available to is the resources available to them from anywhere 24/7 remotely or in the in the land itself on campus? Is it scalable? Is it easy to expand? Right? Is it reliable? Can I 100% make sure that every time I connect to the internet, I'm always there, right? So all of these are different characteristics that you have to take into account when you are designing your LAN, and routers play a big role in this. All right, so the router is responsible for routing traffic between networks. So if you have one LAN right here and another LAN right here, the router when you pass your frame to the switch, what does the switch do? It's a layer 2 switch. He takes that frame, looks at the destination MAC address, looks which port it's going to exit, and let that frame just go to the destination. And then what does the router do when it receives this frame at the default gateway right here? Opens up the frame, pulls the packet out, puts it into another frame, and sends it out to PC2 through the switch, right? Now, typically, this is a routing table. When you type the command show IP route at the privilege mode, it will display the routing table for you. What this is saying, the letter C means that it's directly connected network 192.168.1.0 with /24 is directly connected to fast Ethernet 00 right here. And 192.168.2.0/24 is directly connected to serial 000 right here. And then it goes outside. Okay? Which means if a packet comes in and it's destined to this one, it will send it right here. What happens is if a packet comes in from outside, right? And it has the address 192.168.2.5, right? What is it going to do, the router? It's going to take a look at the destination IP address that was stamped on that packet, .2.5, the 192.168.2.5, and end it, and then go to the first entry in the routing table, and then pick up the /24, the subnot mask, and then end it with that IP address 192.168.2.5. The result is going to be 192.168.2.0. Does that match this network? No. And then that means I don't send that packet to the fast Ethernet 00. What I do is I go to the next entry in the routing table and then add that same destination IP address 192.168.2.5 with this /24. If it's a different slash, then you'll end it AND with that different slash. But since it's the same, you end it with /24, and the result will be 192.168.2.0. Try that, by the way. And 192.168.5.0. I'm sorry, .2.5 end it with 255, 255, 255.0. The result will be 192.168.2.0. So that result matches this entry in the routing table right here. And if that's the case, then you send the packet to the serial 000. That's why it sends it to here. Directly connected means that these are part of the router interfaces. So this is one LAN, one LAN. They're directly connected to the route, to the interface of the router. All right, routers are just exactly like computers. They have a CPU, they have an operating system, they have RAM, ROM, non-volatile, even a hard drive if you need to, although we hardly ever use them, just like the computers had hard drives. For example, in the RAM, these are very good to remember, so you'll know. The operating system, when it moves from the flash memory chip, when it's booted up, it moves from the flash and it goes to the RAM, and it's called the running iOS when it's in the RAM. All right. The running configuration file, when it's located in the NVRAM, it's called the startup config, right? And when it boots up and it goes into the RAM, then it's called the running configuration file. Now, anytime you make changes to the running configuration file, you better save it in the NVRAM because otherwise you'll lose all the changes that you made. Remember we talked about that? The IP routing table, everything that the CPU is using is really in here, in the RAM itself. The ROM chip is where you have the boot up instructions, the basic diagnostic software, and that limited iOS. Like the bootstrap, the bootloader that loads the operating system, the post, the diagnostic software, the limited iOS. This is the core file of the operating system. So in case the flash memory loses the full image of the operating system, so you'll use that limited iOS that's located in the ROM. This is like loading up the in safe mode in the computer, right? And remember, what does the flash have? It has the operating system and some other files that we really don't use as much. This is a very good idea to remember this. So please, here we go. Question number 1. Well, it's not even a question. I want you to write this down as number 1 question. What is in the RAM, ROM, NVRAM, and flash? So create a table and write this down. All right. Here are the interfaces on the back of the router, right? You got the LAN interfaces. This is the default gateways. This is the USB ports that you can use to connect to the router. Now, instead of the console port, if you only have USB port, they allow you to use the console port, the USB ports. Here's the console port that we use to connect to the router, a mini USB. This is where the flash cards are. This one doesn't look like have any. This is where the serial ports, the high, wide interface cards, right? They all can go in here. All right, so the routers, like we've discussed, is the one that interconnect LANs together. So you have a home office LAN, you have a central office LAN, a branch office. You send your data to the router, and router talks to other routers to get you to your destination, right? And you may go through the cloud. This is a private connection, private WAN connection. So this whole thing is called a WAN. Each one of those is called a LAN. And routers is the one that connects these LANs together. All right, so what do routers do? Their main job is to find the best path to the destination. It's like a GPS system, right? So you type in your destination, and your GPS will find the best path to your destination. And but what the routers do is they have a chart called the routing table, the one that we just looked a few minutes ago. And every packet that comes in, I look at the destination IP address. Remember, we do the ANDing to figure out the network portion of that IP. Then I look up the routing table. And then the routing table tells me which interface I need to send the data to so it can be routed out of that interface. Okay. Now, our concern is how does this router find this? How does it get this routing table? How does that routing table gets populated? Okay, that we're going to be talking about that most of this semester too, details. So, for example, when a packet comes in, what does the router do? They go through each line, each entry in the routing table, and try to find it to which interface it's going to send it to out here, right? So like I told you, when a packet comes in, I take the subnot mask address and it with that destination IP address that's stamped on the packet, do the AND, the logical AND process, and the result is try to match it with one of these entries. If it's not, you move on to the next entry and so on. So therefore, you don't really want to have a very large entries in the routing table. You try to make the entries as short as possible because you want the lookup to be quick, right? Static means a static route. That means I went inside and I told the router, if anybody wants to go to 192.168.30/24, send it to serial 000. So when you see the letter S, as you can see, it says static. That means someone typed this address in there. It's not that the route, it's not directly connected to it like the little C's. Okay. These are just codes to explain to you what these codes mean. And we'll see of them. We'll see more and more as we move along. Right now, packet forwarding method. There are three different packeting forward methods. This is the process switching. This is an older way of really looking up the packets. You got a packet coming in the ingress, coming into the interface, and then I look it up the routing table and send it out of that other interface. This is like having a warehouse where you have 4 exits. So depending on the destination IP address, you just send it to the north, west, south, east. On the router, depending on what the destination IP address, you send it to serial 000, send it to 001, 002, depending on what the destination IP address, it's either going to, what is the next router it needs to go to. That's all that the router does, right? Now, there are other methods called fast switching. So this is a common packet forward switching that is used very, very quickly. Instead of just keep looking up the destination address and do the ending, it caches in a lot of the addresses that are already did. So it doesn't have to do the ending process all the time. So if it recognizes this IP address should go to this interface, it does it very, very quickly. Or they have nowadays they have the Cisco Express forwarding method, which is this is very, very quickly. Table entries are not packet triggered like fast switching, but change trigger. So if anything changes, it will send the data as quickly as possible. We really don't have to get into any of these. Just know that the router looks up the destination IP address that is stamped on the packet and finds which interface it needs to go to. Then it sends it to that interface. And once that packet goes to that interface, it gets re-encapsulated into another frame and leaves and sends it out. Okay? So again, these are LANs, and the routers are the ones that interconnect these LANs together. So once your packet goes to the router, it gets encapsulated into another frame. Then that packet gets re-encapsulated in different frames going from one router to another. All right, the default gateway, you all should know that. This is the default gateway of your router, right? So the default gateway means that it is part of the network, first of all, right? Part of the LAN. So if anybody does not want to communicate with a host in the LAN, by default, their computer is going to ask the MAC for the MAC address of the default gateway. So by default, you go to the gateway, get his MAC address, stamp it on the frame, and send your packet to the default gateway. Remember we talked about that last semester? So that's what the default gateway is, and it should have an IP address in the same subnet that this LAN is in. Okay? All right, we usually give it the first IP address or the last IP address. The subnot mask identifies which network you're in, right? So if I take this IP address and end it with the subnot mask, it's going to tell me which network I'm in. The default gateway, of course, identifies who your router is, who's your post office to send the data to when you need to go outside. The IP address, of course, identifies who you are in the LAN and which subnet together. Okay? And this is your frame. Here's your data that's inside. Here's the IP addresses. This is not a MAC address, obviously, right? That's wrong. This is a destination IP address, you see. Now we see something wrong in this. This is a destination IP address, which is the 199.2, right? That's what they, and this is the source IP address, which is the 110 guy. Where's the 110 guy? It's not even, doesn't exist. Anyway, but this does not look anything like a MAC address. It is definitely an IP address. But anyway, let's continue. Okay, so documenting the network that we have. So if you have a topology such as this, PC, for example, this is LAN 1, right? I think we had this done in last semester too, to be able to read the documentation. For example, PC1 should have an interface fast Ethernet 00. They should have actually put, just PC1. And the IP address is 192.168.1.10. The subnet mask is /24 because it's in the same network /24. And their default gateway is this guy, 1.1, right? PC2, 3.10, right? Same subnet mask. And this is his default gateway, 192.168.3.1, right? Routers do not get default gateways. Remember that. So fast Ethernet 00 is the 1.1/24. So this whole network right here is 192.168.10/24, right? This is .1, this is .10. You can have .2, 3, 4, 5, 6, as many people as you want attached to the switch. But the first one is to the default gateway, right? Now, the interfaces of the router, 2.1 is to the serial 000 of router 1. So router 1, serial 000 is 2.1. And router 2 is directly connected to router 2, serial 000 right? So you should be able to identify the addresses on the interfaces and document that in a table that looks like this. All right, enable IP address on a host. We've done that already. How do you type in an IP address statically on a PC? Remember, you go to the computer, the adapter settings, and you hit IPv4. You click in and you type it. You click on IPv4, double click, go to properties, and then choose the button that says to statically type the IP address, and then you type the IP address, the subnet mask, the default gateway, and the DNS server. Or you can choose the button that says automatically assign an IP address. That's going on the DHCP. And we'll set up a DHCP server this semester. The router will act as a DHCP server, so we don't have to keep doing a static IP address and keep track of all these IP addresses that have been assigned to hosts. All right, the LEDs on the devices on the back of the router. Okay, so this is on the speed side. For example, let's look at the gigabit Ethernet. On the speed side, if you get a blink and a pause, that means you're running 10 megabit. If you get 2 blinks and a pause, you're running at 100. If it's 3 blinks and a pause right here, that means it's running a gigabit Ethernet. Okay? If it's green, if the L is green, then you know that this is active. If it's dead, if this is dead, you're not going to get anything right here. If this is just blank dark, that means this interface is not active. On the console port, same thing. This tells you if it should be green. That means if you're active. So is on the USB port. So watch for those. So this is something good to look at when you are, and they should not be amber color. Amber color, you have some misconfiguration. How do you connect to these devices, to the switch or to the router? In our lab, if you have the old PCs, You can use the serial port on the back of your PC, on the back of on the port of the computer, and you use a console cable that looks like this. This port right here goes to the serial port, and the RJ45 connector goes to the console of the router. That's your connection. Then you go to your PC and you turn on either Teraterm or PuTTY. We usually use PuTTY in class. Now, if your PC only has USB port, then you use the type A to type B. You go USB on your computer, you go to USB type B on the router, and then you use PuTTY to get in. All right? So we'll be doing this in class, by the way. All right. Enabling a switch, the IP address on a switch. We've done that already also as well, right? On the switch, the management VLAN is by default is VLAN.1, VLAN1, remember that. And if you give VLAN1 an IP address, so you type interface VLAN1 and you give it the IP address and the subnet mask, you type no shutdown. Now anybody will be able to telnet in that LAN to telnet into the switch. So PC1 should be able to telnet into the switch if he has the same, he should be in the same subnet. Now, if somebody from outside wants to telnet into the switch, that data when he's telnetting going back and forth has to go through the default gateway. So therefore, the switch needs a default gateway where to send the data to when it's going outside the LAN. So how do you give an IP address a default gateway to the switch? Make sure you are at the config mode and you type IP default gateway 192.168.10.1. So 10.1 is the default gateway of that switch, right? If you don't want anybody to be able to telnet from the outside into your switch, don't give it a default gateway. So only these people will be able to telnet into the switch. That means you were really telnetting into your switch from your office, maybe, right? All right. And to be able to telnet, you got to set up the passwords, right? Enable secret, you do the console password. Remember we did that. And here's how you set up the VTY password. This is the initial configuration of a router, and we did this already the last semester. And you configure a banner, save the configuration, and you could type in the IP address on the gigabit Ethernets, right? You can do IP address on the gigabit interface, right, on the router, give the IP address IPv6 address. Remember that? We did that too. Configure a loopback address also on the router that you can telnet. Verify the setting by typing show IP route, right? Show IP interface brief, show IP route displays the configuration, displays the routing table, right? Show running config, show the running configuration in the router. In the RAM. Show interfaces, shows you all the interfaces and how they are configured, and show IP interfaces specifically for the IP and how the IP configuration has been done to those interfaces. You can type show IPv6 brief to show you how the IPv6 been configured, right? You know what? Let's take a look. Let's go in and do a quick packet tracer on quick review. So let me take a 1941 router, okay? And I'm going to take a switch. Oops, no, don't take any switch. Just click on switches and take the 2960 switch, but run right here. Okay, just one enough. And you know what? Let me pick up two PCs. Okay. And let's connect them. Okay, the straight through cable. Go to the PC0 fast Ethernet, put it on fast Ethernet 1. Take PC1, put it on fast Ethernet 02. And take another one and put a fast Ethernet 03 to the gigabit 00. Okay. Let's assume that this network is 192.168.10.0 with slash 24, right? We're going to give the first address to the PC. I always do, oops, let me just click here. The first address to the PC. So let's give this first address to the last address is going to be to the default gateway, right? So this is how you would go about doing this. Click 192.168.10.1. Subnet mask is slash 24 and the default gateway is 192.168.10.254. That's the last address. Okay. Click right here. Go to desktop. 192.168.10.2. Tap. The default gateway is 192.168.10.254. Okay, that's it. Let's go on to the interface right here, CLI. Remember how we were able to use the console port? You know what? Let's do that instead of typing CLI. Well, you guys know already. I'm not going to do that. Just type no. And here's the basic router configuration that you should do. First thing you should do, type en config t. Remember, I'm going to ask you to submit this. So if you are just watching, pause it and redo all of this because I want you to submit this as homework when we're done. I want you to go over this. So you type en config t. Let's give it a host name. Host name R1. Disable the DNS lookup by typing no IP domain lookup. Okay, let's create a banner. Message of the day banner. MOTD space quote. You will not have access to the router between 1 and 3 p.m. Close the quotes. Okay, just a message of the day. Now, let's do the line console for anybody that's trying to go into the limit the access to the console port. So line console, password Cisco, and let's do login. All right. And if somebody let's do the line VTY 0 to 4 because it's a router. And then the password is Cisco 1. Oops. I misspelled password. So I'm hitting the upper arrow key. Password Cisco 1. Right? And then you type login. Let's do the enable secret. Let's go, let's Cisco 2. Oh God. I'm spelling enable 2. All right, so enable secret Cisco 2. That's really the basic configuration of the router itself. Now, let's go to this interface right here and the default gateway and give it the IP address. So you type INT FA0, not FA, it's G0. It's G0/0 and give it the IP at 192.168.10.254 with subnet mask 255.255.255.0. Right? Before we type no shot, let's give it the IPv6 address. IPv6 address 2001 colon 0 DB colon ACAD colon 1 colon 1 slash 64. Remember we did that? Okay. And then you type no shut. So I gave this an IP address, IPv4, an IPv6 address in case they need to use an IPv6. And then type no shut, and the interface goes up. Now, if you remember, how do I make sure that this PC gets the link address automatically? See, when you do auto config, it doesn't get anything. No good. So what do? You go to the router, make sure you are at the config mode, and you type what? IPv6 unicast routing. Okay, once you do that, okay, now we got to also go to the interface. That's it. Then you go to right here to the PC, and bingo, now you got his IP addresses. Remember the Slack that we talked about? So PC2 will get his also IP address automatically from the Slack and the default gateway IP address. That's the basic configuration of the router. Now, of course, you can give if you remember, we give the unicast if you type, for example, let's do Control Z and type show IP, show interface. So IP, INT, brief. Okay, so I see that the interface gigabit 00 is up. Let's type show IPv6 interface brief. And there you go. Remember how we do the FE and change that using the max, the EUI 64? We want to change that to a 1 also. So it can match the host of the global address. You want the link local to host to always match the global link. So how do you do that? You go config T, you type interface giga 0/0, and you say IPv6 FE80 colon 1, and then you type LI and hit the tab key. I'm sorry, /64, and then you say L. Did we type in? Oh, we forgot to write the command IPv6 add. IPv6 add 64, and then you write link. Oh, you don't have to write 64/64. You just say link local, and that's it. So you type in IPv6 add FE00, FE80, link local. Now, if you do controls or do the command do show IP IPv6 interface brief, and now that's good, right? And you will go. All right, and that's it. So now you configured IPv6 and IPv4, and the PCs have, as we said, using Slack, they get their IP addresses automatically. Oops, what happened? It crashed. Anyway, packet tracer stopped working. All right, before I finish up, you see that the default gateway was changed to the correct address. It crashed, so I got to bring it down. You guys make sure you save this and you submit this as homework. All right? Anyway, we're done. All right, let me just close it. I don't need it. Let's get back to here and let's continue. All right, so here is to verify the interface settings. You type IP show IPv6 interface brief. So it shows you the IPv6 interface brief on both of them like we did just before, right? You could type show IP interface brief, show IP interface with the pipe. When you use the pipe command, you can use the commands either section, include, exclude, or begin. If you say include, that means you only want a specific something to be showing up. So for example, include whatever is the word up. So it will only display the interfaces that are up, right? If you say exclude unassigned, it does the same thing really, right? So when you use the pipe, it's going to shorten the number of lines that is being displayed because otherwise it will display everything for you. Terminal length number, you can, when you hit show run, for example, it's going to show you, for example, uh, every 10 lines, if you write 10, 20 lines before it pauses. If you write 0, that means everything is going to be scrolled up. So remember, terminal length and the number will pause the execution of your command after a certain number of lines have been displayed. I never use the control P. You can use the keys control and the letter P, and it repeats the command that you did. But I use the arrow key, the upper arrow key or the down arrow key to do that. It remembers by default the 10 last commands that you did. By type, you can use that you use the command show history to do that for you. If you want to change from 10 to 20, just you want it to remember the last 20 commands that you did. Just stop terminal history size, and then you can change the number to whatever you want. All right. How does the router? What does the router do when it grabs a frame? Remember, your PC encapsulates the data from layer 7 to layer 1. When it goes on the packet, it goes into frames, in bits actually. He receives the frame, but he opens up the frame to layer 2, looks at the packet, decides where it's going, then re-encapsulate that packet into another frame, and then goes out to router 2. And router 2 does the same thing, grabs the frame, opens up the frame, pulls the packet out, and then re-encapsulates it and so on until it gets to the final destination. All right, when you want to send the packet, you send the frame, right? He looks at the destination IP address. Remember we talked about this last semester, I think. Yeah, we did. When you send a frame, he checks out his MAC address, make sure it's his MAC address, right? This is the destination 0010. He pulls the packet out of that frame, throws the frame in the garbage, and then gives it to this guy right here. And he puts in that frame in that packet, puts the packet into another frame and sends it out. He's going to have his source MAC address and his destination MAC address on that frame. But look at the IP addresses. The 1.10 is the source. This is the sender. The 4.10 is the destination. The packet never changes. It's just the source and the destination MAC addresses that are stamped on the frame that keeps changing as you traverse the network. You see, now he is the source, right? The 0020, and he's the destination, right? 0B31. But the packet and the IP addresses 110 and 410 do not change. And it just keeps going, as you can see. So study this. This is very important because Cisco love to test you on stuff like this. All right, so when a frame comes in, I pull the packet out. Then I grab in the search, the routing table if there's a match to a destination IP address. If not, you just keep going. Now, if there is no match in any of the entries in the routing table, what does the router do? It immediately throws the packet in the garbage. All right, so again, how does the router learn all of these different entries in the routing table? Again, you can do that either by statically or dynamically. Dynamically meaning there are dynamic routing protocols such as RIP, OSPF, or EIGRP. They go out and the routers talk to each other to decide which is the best route to take for any destination that you want to go to. For example, if you use a dynamic routing protocol RIP, it uses the metric hop count, which is the shortest distance to the destination. If RIP thinks the shortest distance is the quickest way to get your packet to a destination. OSPF, well, he thinks it's the best way is to look at the fastest speed Now it's like it's like a GPS that looks at the highway speed, but RIP looks at the shortest distance, the quickest way to get there. You know, which is better? Is it the shortest distance or to take highways? Well, probably highways because shortest distance meaning the speed could be slow. There's a lot of stop signs, there's a lot of delays, but Rip doesn't care. He thinks the shortest distance is the quickest way to get there, and that's why what he uses. But OSPF looks at highway speed. But the problem with also looking at just bandwidth, like quote unquote highway speed, is there may be delays there. EIGRP not only looks at highway speed, which is the bandwidth, but sees if there's any delay, if the load is okay, if it's a reliable route or not. So EIGRP is a little bit more sophisticated because it uses more metrics in calculating the best route to the destination. Now, if you have multiple routes of the same speed, or all right, or equally same speed, same delay, what are you going to do? What you do is you spread out uh, the data to all paths. That's called load balancing. So you get their data goes much quicker. All of them support equal cost loads: RIP, OSPF, and EIGRP. Now, every routing protocol, including static routing protocol, is assigned a number called administrative distance. The lower the number, the more reliable the route is. Okay? So for example, if you on your router you're running RIP2, you're running OSPF, and you're running EIGRP, and they all went out and found different routes for you to go to your destination. Your router is going to choose the route that was found by EIGRP. Why? Because EIGRP, the internal EIGRP, is assigned an administrative distance of 90. That's the default, by the way, because it has a lower number, 90, lower than OSPF, which is 110, lower than RIP2, which is not even shown here, which is 120. And therefore, EIGRP will be used. Therefore, you should not use more than one routing protocol on a router because the others will not be picked anyway. Well, actually, you can use them as a backups, which we'll discuss some other time, not today. Now, these are the defaults. You can change them. And why do you, if you asked, why is EIGRP given a smaller number than OSPF? That's because EIGRP is a little bit more sophisticated software and it uses more metrics, as we've discussed just a few seconds ago. It uses bandwidth plus delay to calculate the best route to the destination, plus the load, plus the reliability. And OSPF only uses one metric, the bandwidth. So, and by the way, you can change these so they are changeable. Now, directly connected has a zero administrative distance, which means you're right there. You don't need to be routed anywhere. Static IP address, that means if you typed in that IP address to the router will use that address, that destination, regardless of what routing protocol is running. Okay, so it has the best administrative distance after being connected. All right, so directly connected means 1, 2, 3. These are the directly connected. The remote routes are these guys that are far away, right? Next hop means if somebody on router 1 wants to reach network 10110, that packet has to go to the next hop, which is right here. Right here, that's your next hop. 209.165.200.226 is the next hop for R1. The exit interface will be this guy right here. So the packet leaves here and goes to the next hop, which is here. Okay. All right. So we just told you what directly connected route. The local route interface is added to the router table when an interface is configured. So that's always comes up. The directly connected also comes up when you type in an IP address on the router, when you configure a router. Static route is when you tell the router which route to take. Dynamic routing is when you're running a software to figure out the routes that are going to your final destination. Okay? So here's a routing table resources right here. It tells you all the different types of router that you have, the codes that you need to look at the entry in the routing table. Here's a typical entry that is used when you see the letter D. So you go and look up D and it says, oh, this entry must have been learned from the, you know, from a directly connected router that's running EIGRP because D says EIGRP. This is the destination IP address with the subnet mask. This is the administrative distance, 90. This is the bandwidth plus delay calculation plus the load, right? And this is the next hop address, right? So this is saying, the router is saying, if anybody wants to go to 10110, should be sent to the next hop right here. And by the way, they usually type in the serial interface exit, which doesn't even have it here, right? So this is identifies the network learned and so on. So here's what I want you to do for question number 2. I want you to write this entry in the routing table and take each one of those and write these down because that's very important. This tells you how the network was learned. In this case, it's from EIGRP. This part tells you the destination IP address, the destination network. This number tells you the administrative distance and so on. This number tells you the exit interface, and this number tells you the next hop. This is how long ago I have learned it. I want you to write this down because when we're looking at the entries in the routing table, this is going to be very important. Okay, so please write these down from here to here. That will be question number 2. All right, so link local is the IP address of the interface. The directly connected is the network. And they always come up automatically every time you configure an interface. Okay? And as long as it's active. So you can type in show IP route with a pipe begin with the word gateway. So here's your default gateways with the link local. And this is for show IP route, by the way, displays the routing table. So you got the 11.1 and the 11.2. It doesn't show anything else. It does not show anything that's been learned from router 2. So this is just to show you that you can use the word begin instead of displaying everything in the routing table. You could do the same command with show an IPv6 routing table, right? Static routes are the routes that are typed in. For example, if you know which route the packet is going to go, so it is best to type in a static route. So you type the command IP route space, the source address, the destination address, the destination max, and who's the next hop where you're going to send it out to. We'll learn how to do this, by the way. Now, to make sure that your routing if a packet does not match any of the entries in the routing table, you want it to go to a specific interface. In other words, you don't drop it in the garbage, and you use the command IP route quad zeros, at which interface it's going to go to. For example, excuse me, if you received a packet and you look and you checked every single interface and none of them matched, what are you going to do with that packet? If it does not have a default static route configured, that packet goes in the trash. So by typing a static default route and sending it somewhere else, will prevent from the packet from being thrown out, and therefore it'll be routed to another router and maybe that router knows where the destination is. Okay, so this is how you insert a default static route by typing IP route quad zeros quad zeros. By the way, we're going to talk about this in chapter 6, static routing. So we're going to spend the whole chapter on how to do all of this stuff. Okay, so here, the default, after you type that quad zeros, 000 serial 000, so it'll go right in here. An S with a star means a directly serial 00. Now, in other words, if I check all these entries in the routing table and nothing matched, then I'm going to send my packet to this exit interface, serial 000. Right? Again, we'll learn how to do that next semester. Not next semester. What am I talking about? In chapter 6. All right, so this is pretty much the same thing. IPv6 static route, same thing. This is the quad zeros. So you say IPv6 route, colon, /0, send it to serial 000. Pretty much the same thing, right? Just using an IPv6 address. Dynamic routing means I'm running EIGRP and you're running EIGRP. So what I'll do, router 1, is I'll tell you that here are my networks that are attached to me. I send it to you in an update. And you do the same thing. You take your routing table and give it to me too. And this way I'll build my routing table according to the information that I received from you. And you load your routing, populate your routing table according to what I send you from my updates, right? And that's how dynamic, and it's much easier that way, right? Let the routing protocols figure out the best route to the destination after they receive the updates from everybody around them. And there are 4 different routing protocols: EIGRP, OSPF. The is nobody really uses this. The intermediate system to intermediate systems, and RIP. The most popular for non-Cisco vendors is OSPF. But if you have Cisco routers, it's most likely it's EIGRP. RIP is nice, and it's still being used especially in old routers. Okay, because this is really the mother of routing protocol, started with Novell. All right, so here is the D's means this is a default route using that's been we'll talk about that too when we talk about EIGRP. This is a default route that's been sent by EIGRP. D means it's for the program that's running EIGRP. It's called dual, DUAL. That's why they give it the letter D. Anyway, IPv6 is different routing protocols. They're not the same. There is RIP next generation, OSPF version 3, EIGRP for v6, and the MP BGP4. We'll be talking about the top 3 later on. Show IPv6 route displays the routing table for IPv6, as you can see. And that's it. All right. So hopefully this was an informative chapter. I think I asked you 2 questions and plus the packet tracer. So submit those for homework. And until we meet again for chapter 5, keep up with your readings, and I will see you in chapter 5.